How you doing? So, I don't know if you can imagine one magnet can pick up a piece of metal, okay? As long as it's ferrous metal, that magnet can do it. Now, what I'd like you to do is imagine two magnets. Right, so imagine two magnets and then they clip together. Right, those two magnets, they can pick up twice the amount of metal. So when you add magnets together, they increase in power. So now imagine three magnets, so you've got more power. Then imagine four magnets. Now quite clearly I can carry on and just, there's 8 magnets. Now magnets usually align like that, don't they? Okay, in a long line. They usually align up in a nice long line. But as we know in space, when you allow water to coalesce, it coalesces into a sphere, and they're called atoms. Oh, they're molecules actually, but they're made up of atoms, and they coalesce into a sphere. Then, if you can just imagine angular momentum, and angular momentum is basically when you take the plug out of a sink which is full of water and watch the water, it doesn't just go down like that, it starts spinning like this into the plug hole. That's angular momentum, just imagine that. Now then you have to take for granted that there's a proton at the centre of a hydrogen atom, and there's an electron which is circulating it. Now the electron is attracted to the proton because the electron is negatively charged, electromagnetically negatively charged, and the proton is electromagnetically positively charged. So as we know, plus and negative will attract, or north and south attract kind of thing. So the electron zooms its way towards the proton. As it gets close, it goes into something called angular momentum, and the closer it gets to the proton, the more attractive the proton is to it. But in the angular momentum, as it gets closer in its spiral, the faster it goes as well. So as it gets closer in angular momentum, it speeds up, and the closer it gets, the more energy it's supplied, because it's more attractive closer in. So the closer it gets, the more attractive it is, the more energy it's got. The more energy it's got, the more it tries to get away. But the closer it is, the more attractive it is. So it's trapped in like a breathing motion of trying to get away, but trying to be pulled in, trying to get away, trying to be pulled in. Now, although the electron doesn't weigh a lot, the faster it goes in a circular angular momentum, the more gyroscopic force tries to fling it off. That's the point I was trying to make. That's how it tries to go away and come back in, go away and come back in kind of thing. And that's pretty much what life is like. And you get sphere. I mean, quite clearly it's not a long thin line, it's not a string anymore, is it? It's now a globe. And we quite well know that everything inside the whole of the universe is spherical. In fact, the universe is spherical. Right, but the point that I'm trying to get is, the two magnets in the centre there have got more pressure on them now than the magnets on the outside, because they're being compressed together by the extra magnets on the outside. So there's actually more pressure on those. So let's get to the point now. Now imagine the first thing that happened in the universe was something I call small thing. You can call it a graviton if you like. Call it graviton if you like. If you want to, I'll call it small thing, ST, in my theories. And ST do something called mitosis. That's where you get one and it starts growing bigger, and then it splits off into two, and then those two, they start growing, and then they split off into 4, and it starts growing, like, yeah. And because the growth of the skin, let's say, because it's easier for me to say just growth of the skin, is a stretching motion, it creates electromagnetism down its surfaces. And that electromagnetism keeps the small thing together. Remember back to the start of the video where the 2 magnets keep themselves together? And they're breeding. They do mitosis. And there's nothing else. These are the first things that ever happened. And that starts getting interesting. So I'm going to start getting close to the camera. So these small things are multiplying, and they're in a sphere because it's all magnetic and it's all holding itself together. And it's getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. Around the outside of it, there is no universe, there is no space. These are the space. This is the space that's going to become our universe. It's getting bigger and bigger and bigger and bigger. And the poor little small thing in the centre, which is trying to reproduce and try to mitose, is finding it harder and harder and harder because there's more small thing around the outside reproducing, getting bigger and bigger and bigger and bigger and bigger. And you might be getting carried away at this point and going, oh yeah, bigger and bigger and squashed in the centre, and that's gravity. But oh no, look, the magnets together, right? The ones on the outside have got less pressure on them, but the ones in the centre have got more pressure on them. We've not even got to gravity yet. We're still talking about an accumulation of magnetic force. And the poor little small thing right in the centre of the big globy sphere thing, the poor little small thing in the centre is feeling a little bit tight and compressed now, because the build-up of magnetism, which as you put magnets together, they can pick up more things, they get stronger. So the build-up of magnetism is getting stronger and stronger and stronger and stronger. And eventually, fusion will happen. Well, this is small thing fusion. This isn't like atomic fusion, because there isn't such thing as an atom yet. These things have got to make an atom. These small things have got to combine together to make up smaller, the subatomic elements, the subatomic particles. So, you know, like a gluon, or a W or a Z boson, or a photon, or an electron, or a neutrino, or a charm, or an up, or a down, or a strange quark. So I've gone through leptons, quarks and bosons there. These are all made up of small thing, because small thing came first. As you can quite clearly see that I've edited this video quite a lot. I just sat here ranting at my computer for ages. But I'm cutting the video short there because hopefully you've got a realisation of what the primordial universe was like and what the first things are like, the building blocks of a universe, the building blocks of a first star. So I had to look in subatomic for what I wanted, and that's where I focused a lot of my reading and my time and effort in the reading the scientific stuff was in subatomic. And other people that have read subatomic for me, because let's face it, you don't have to read all about subatomic stuff to get knowledge. You can read other people's condensed knowledge, because they'll read it and then they'll condense it and take out the contradictions, just like what I do. Sometimes I'll read a whole section of someone's research, someone's real research, and you'll see all the contradictions. You just pick the contradictions out and you figure it out. But anyway, faster than light speed travel has now been proven through the picture of a black hole feeding on matter in space, ejecting mass ejections, basically, I suppose you should call them. And they travel faster than the speed of light because, quite clearly, nothing, even light, can escape from a black hole, is what it said. That's why you can't see them. But now we've found a couple of black holes which are feeding on stars, and quite clearly they eject things. And we've got things called dark matter and dark energy. And I believe, well, my theories lead to black holes recycle atomic matter into subatomic matter to recoalesce through a process that I call enlargement. Go read about it, or go and watch my videos. They're interesting, funny, sad, true, perplexing, infuriating, and all manner of things. Everything that you need in life to be of interest, go watch my video. That's what I got for you. Faster than light travel.